Good evening students, welcome back. Welcome to Yupp Master, the school foundation program, and I am your chemistry teacher Dr. Sripad Rao. So in the last few classes we people are focusing on the nomenclature of the branched chain alkanes. So when branch is present on the alkane chain, how to name that particular alkane according to IUPAC we have seen. Okay. So let us move on to some more examples of the nomenclature, as well as there are one more rule we have not discussed with respect to the complex substituent when it is present on the alkane chain, and how to name that complex substituent if it is present on a alkane chain. So let us focus on those concepts. So before we go into the complex substituent, let us take some examples with respect to the similar substituents when they are present on the alkane chain. For suppose when we have let us say the methyl groups like this CH3, CH, CH3, CH3. So how to name this particular alkane, branched chain alkane? So first and foremost thing is to select the longest carbon chain which is containing maximum number of carbon atoms. The continuous chain we have to select. So I am selecting the continuous chain, and after selecting the continuous carbon chain, we have to number the carbon atoms such that the substituted carbon atom gets the lowest possible number. Okay. So let me proceed from left to right. 1, 2, 3, 4. Okay. Otherwise if we are going in a reverse way around, if you are coming from that side, let it be 1, 2, 3 and 4. Now in this case if you go from left to right or right to left, the numbering will be the same. In this case at second carbon atom we have the substitution, at third carbon atom we have the substitution, and similarly in other case as well, if you observe, the second case or second carbon as well as the third carbon are having the substitutions. Okay. Now when you look at the substituent, what is that substituent group that is present, alkyl chain that is present on this particular chain? It is CH3. So methane, one hydrogen less than that of the methane, so we call it as methyl. Alkane minus hydrogen, we call it as alkyl. So methyl substituents are present on this carbon chain. Now, so how many carbons are present in the longest carbon chain? 4 carbons are present. So it is a butane is the parent chain, and on the butane chain we have methyl substitutions at the second carbon atom as well as on the third carbon atom. So how to write them? Since the substituent present is similar kind, or the same substituent is repeated twice in this particular chain, so in that case the naming should be given as 2, 3 hyphen, then you have to write dimethyl. 2 times the methyl is present, so I am writing dimethyl. And what is the parent chain? It is 4 carbon chain. So 4 carbon chain containing alkane is butane. So it is 2, 3 dimethyl butane is the name of this particular compound. Okay. And similarly, let me take one more example. If the 2 methyls that are present on the 4 carbon chain, if they are present on the same carbon atom, in that case how to name it? So this is the situation now. We have CH3, C attached to 2 methyls, CH3s, CH2 and CH3. Okay. So now we have to select the longest carbon chain containing maximum number of carbon atoms. So I am selecting the longest carbon chain containing maximum number of carbon atoms. So here if you observe, the longest carbon chain contains 4 carbons, so it is butane, and numbering should be given in such a way that the substituted carbon should get the lowest possible numbering. So if I move from the one side to this side to this side, that is left to right, in that case this carbon gets the lowest position or this lowest number. Okay. So moving in that direction, this is first carbon, second carbon atom, third one and the fourth one. So if I move in other direction, what happens? The substituted carbon gets the third position. So that is not the correct way of numbering the carbon chain, which we have discussed in the previous classes. Okay. Now if we observe here, on the second carbon atom, we have 2 methyl groups. 2 CH3 groups are present on this particular carbon chain, right. So similar substituent is present, so we have to use di in this case because we have the similar substituent present 2 times, so we are using di prefix before the name of this alkyl chain, and it is a methane minus 1 hydrogen, so it is a methyl. So dimethyl is present. Where it is present? It is present on the 4 carbon chain, exactly on the second carbon atom. On the second carbon atom we have the 2 methyl groups, okay. So now again we have to mention their position also, the substituent name as well as their position has to be mentioned according to IUPAC. So mentioning the position, I am writing it is 2, 2. So two substances are present, so I am writing 2, 2 dimethyl, okay, 2, 2 dimethyl, 4 carbon chain, so it is butane, okay. Students, you have to identify the substitution and you have to identify the location of the substitutions as well. So the substituent name that is present on the parent chain, not only the substituent name, also its location on the parent chain is very, very important in naming the alkane, substituted alkanes according to IUPAC nomenclature. So this compound is 2, 2 dimethyl butane. 2, 2 dimethyl butane. This is IUPAC name. What is the common name of this particular compound? If you observe how many carbons are present, 4 carbons in a chain, 2 carbons as a substituent, so total 6 carbons are present, and second last carbon atom having the 2 methyls, then we use neo terminology. 6 carbons are present, so hexane. 2 methyls are present on the second last carbon atom from one end and no other substitutions are present, so therefore it is neohexane. So this compound common name is neohexane. Common name is neohexane. IUPAC name is 2, 2 dimethyl butane. Okay. So you have to be very careful while handling the IUPAC naming. Okay, don't confuse with the common naming system. In common naming, total number of carbons are counted and the alkane name is mentioned, but according to IUPAC, the longest carbon chain containing the carbon atoms is taken as a parent chain. Okay, let us see some more examples with respect to the nomenclature. Let us say we have 5 carbon chain CH3, okay, CH, CH3, CH2, CH, CH3, CH3. So this is one way of the compound having 5 carbon atoms with the 2 substitutions, and let me write one more the similar fashion, CH, CH3, CH, CH3, CH2, CH3. Okay, so almost same compounds, but the substitution locations are different. So in first case, if we observe, if we are going to select the longest continuous carbon chain in the first one, so this will be the longest continuous carbon chain containing 5 carbon atoms. So 5 carbon atoms are present. So what will be the parent name? The parent name is pentane. Okay, parent name is pentane because 5 carbons are present. Now number the carbon chain either side, you can go in any direction such that the substitution carbon should get the lowest possible numbering. So if I go in this direction 1, 2, 3, 4 and 5. Okay, so if I come in the other way around in the reverse direction, this will be 1, this will be 2, this is 3, this is 4, this is 5. So I have numbered the carbon chain, continuous carbon chain, longest carbon chain in the particular given compound, and numbered according to the given concept. And in any direction, if you see, in first case, the second carbon has the substitution, fourth carbon has the substitution. Okay, and in the case of the reverse way of numbering, you can clearly see at the second carbon we have substitution and fourth carbon we have substitution. So in both the direction we are getting the same numbering system. So you can number in either direction. You can go from left to right or right to left, no problem in this case, right. So if you observe, let me take the first one, okay, let me take this one. So here if you observe at second carbon we have CH3, at fourth carbon I have CH3, okay. So similar substitutions are present at a second and fourth carbon atoms. So therefore I have to mention their position with using di before the name of that alkyl group, okay. So if I write the positions, at second carbon I have methyl group, so it is 2 comma, at fourth carbon also I have a CH3, so it is 4 hyphen, and then we have to write how many times it is present. It is present 2 times, so I am writing di, okay. Then I have to mention the alkyl group, that is methyl, dimethyl. How many carbons are present in the parent chain? 5 carbons, so parent name is pentane. So it is 2 comma 4 dimethyl pentane is the name of this particular compound, okay, right. So now coming back to the other compound that is given there, if you observe here, selecting this particular carbon chain, longest carbon chain containing 5 carbon atoms, okay. Now I have to number the carbon chain from one direction so that the substituted carbon atoms get the lowest possible number, right. Now looking at the numbering system, 1, 2, 3, 4, 5. If I am numbering from left to right, it is 1, 2, 3, 4 and 5, okay. So if I am coming in the opposite direction, in that case this carbon gets the first priority, second one, third, fourth and fifth. So I have numbered in either direction. But if you observe the substitution, the carbon atom getting second in this case when we are moving from left to right. So one case I am getting 2 and 3 for the substituted carbon atoms. If I am moving from right to left, in that case I am getting the substituted carbon 3 and 4. So if you take the sum of the two locands, in this case it is 2 plus 3, 5. If I am coming in the reverse direction, then it is 3 plus 4, so it is 7. So according to the IUPAC, the sum of the locands should be the lowest possible. So the 2 plus 3 equal to 5 is the correct way of numbering the carbon chain, okay. So I am numbering the carbon chain from left to right such that the substituted carbon gets the lowest possible number, and when we go for the sum of the locands, the sum should be lowest possible. So 2 plus 3, 5 is this lowest sum, whereas if I am coming from right to left, in that case the third carbon and fourth carbon has the substitution, so 3 plus 4, the sum is equal to 7. So sum of the locands is 7 in this case, sum of the locands in one direction is 5. So we should always prefer the lowest sum rule, okay. So the first way of numbering, this way of numbering is correct, the other way of numbering is wrong, right. So now we have decided the correct way of numbering in this case. After that, what we have to see? We have to look at the substitution that are present on the parent chain. So the substitution that is present here, it is CH3, here also it is CH3. So similar substitution, same substitution is present 2 times. So again we are going to use di-alkyl. In this case it is methyl, so it is dimethyl. So before dimethyl we have to indicate their location, where they are present, where that methyl group is present. So on the second carbon as well as on the third carbon the methyl group is present. So we can write it as 2, 3. 2, 3 dimethyl, you have to write a hyphen after the numbers and then we have to write the dimethyl. So total number of carbon atoms present in the parent chain is 5, so it is pentane. So this is 2, 3 dimethyl pentane. The name of this particular compound is 2, 3 dimethyl pentane. Name of this compound is 2, 4 dimethyl pentane. So this is a pentane chain having 2 methyl groups. This is also a pentane chain having 2 methyl groups, but their locations are different. In one case the methyls are located at second carbon as well as 4 carbon. So we are writing their position 2, 4. So one methyl is present on the second carbon atom other methyl is present on the fourth carbon atom. So we have two methyl, so I am writing dimethyl. So it is to indicate there is no need to write methyl methyl two times, okay, just write dimethyl. If we have three methyls, write just trimethyl, and then the parent name has to be given. So the parent has 5 carbons, on these 5 carbons, on the second carbon we have methyl, fourth carbon we have methyl group. Similarly, this case pentane is the parent chain, so we have a 5 carbon parent chain, on that on second carbon atom we have a methyl group, and as well as third carbon atom we have a methyl group. So it is easy for us to even write the structure of a compound from the name, or it is also easy for us to derive the name from the structure that is given. So we can go in either direction. According to IUPAC, a single structure will have a single IUPAC name. A IUPAC name will have a single structure. So you can go in either direction, structure to name or name to the structure. Okay, right. Let us take some more examples with more number of substitutions, similar substituents 3 times when they are present on the parent chain. For example, let me take the same 5 carbon chain so that we can easily identify how we are going to write them. CH, CH3, CH, CH3, CH, CH3, CH3. Okay. Now we have 3 substitutions on the parent chain. So first of all, we have to identify the longest continuous carbon chain, so which has maximum number of carbon atoms. So this is the longest carbon chain. Okay. Now I have to number the carbon chain in such a way that the substituted carbon should get the lowest possible numbering. So if I am going from left to right, okay, 1, 2, 3, 4, 5. I have gone from left to right, I have given the numbers from left to right. Let us give the number from right to left. So this is 1, this is 2, this is 3, 4 and 5. Okay. Now you can identify that when we are moving from left to right, numbering the carbon chain from left to right, in that case the methyl substitution is present on the second carbon atom, substitution is present on the third carbon atom, substitution is present on the fourth carbon atom. We have 3 substitutions in this case. On the parent chain, 5 carbon parent chain, we have substitution at the second carbon, substitution at the third carbon, substitution at the fourth carbon when we are moving from left to right in this particular compound. Similarly, if we are going in a reverse direction, when we are numbered the carbon chain from right to left, in that direction if you observe, at second carbon we have a substitution, at third carbon we have substitution, at fourth carbon we have substitution. So if you observe second carbon, when we are moving from right to left, when we are numbering the carbon chain, when we are numbering the parent chain from right to left, in that direction if you observe, on the second carbon we have substitution, on third carbon we have substitution, on fourth carbon we have substitution. So in either direction, in the left to right direction, second, third, fourth carbons have the substitution. In left to right, right to left direction also, second, third, fourth carbons are having the substitution. So if you are moving in either direction, left to right or right to left, both are giving the same kind of numbering to the substituted carbon atom. So don't worry, you can take any one, you can select any one of the numbering system, right. So if you take the sum also, 2 plus 3 plus 4, 5 plus 3, 4, 9. Here also the sum is coming out to be 9. So sum of the locands in the both the directions is 9 only. Right. After giving the numbering, what we have to do? We have to identify the substitution that is present on the parent chain. So when you look at the substituent that is present in this particular parent chain, you can clearly observe that we have a methyl group here. Here also we have a methyl. Here also we have a methyl. So same substituent is repeated 3 times. It is repeated 3 times. So therefore we are going to use tri while naming the IUPAC. So there is no need to write 3 times methyl, methyl, methyl. Just to use tri and then write the alkyl name. So it is the substitution is trimethyl. Okay, where they are present, what is the location for these substitutions? So at second carbon we have substitution, third carbon we have substitution, fourth carbon we have substitution. So therefore I am writing it as 2, 3, 4, then hyphen trimethyl. What is the parent chain contain how many number of carbon atoms? In this case the parent chain contain 5 number of carbon atoms. So when we have 5 carbon chain, the name is pentane. So it is, parent name is pentane. So total name if we observe, it is 2, 3, 4 trimethyl pentane. What is the name? 2, 3, 4 trimethyl pentane. So first is to select the longest continuous carbon chain having maximum number of carbon atoms, and then number the carbon chain in such a way that the substituted carbon gets the lowest possible number if we have only one substituent. If we have 2 or more than 2 substituents, in that case the numbering of carbon chain should be such a way that the sum of the locant should be the lowest possible number. Okay. So after giving the numberings, we have to identify the substituent that is present. So since we are dealing the alkanes, so we are taking only the alkyl groups as a substituents. So alkyls we have to identify. Alkyl name is given by removing one hydrogen from alkane. Methane becomes methyl, ethane becomes ethyl, propane becomes propyl, butane becomes butyl, pentane becomes pentyl, etc. So you can write accordingly the name of the alkyl substituent that is present, and while writing the name of the alkyl chain that substituent that is present, we have to indicate their position on the parent chain. So in that case therefore we are writing the numberings. The numbers are separated by commas and the number and the word separated by an hyphen, and then we have to write the substitution's name, then we have to write the parent chain, and there should not be any gap between the substitutions and the parent name. So it should be a continuous word, only one single word we have to use for writing the IUPAC name of the compound. So here I have written elaborated structure for the given organic molecule. Okay. So there may be some cases or instances where we are going to have a zigzag representation of organic molecule. So in that case, how to identify the longest continuous carbon chain? For example, if they given us like this, okay, and they have given substitutions like this. Now this is a zigzag representation of carbon compound. So we have to select the longest continuous carbon chain. So I have to use this in order to select the continuous carbon chain. So I have selected the continuous carbon chain now. Okay. So of course it leads to a little confusion. So in order to select the continuous carbon chain, let me write or let me number the carbon chain in such a way that the substitution should get the lowest possible number. So the continuous straight chain in this fashion is the longest carbon chain. So I am numbering the carbon chain such that the substituents gets the lowest possible number. Now if you observe, the longest continuous carbon chain contain how many carbon atoms? 6 carbon atoms. So 6 carbons are present in this particular alkane chain. So parent is hexane, parent name is hexane, okay. And then look at the substitution that is present on this particular carbon chain. What are they? The substituent, if you observe, they are present at the second carbon and also on the third carbon atom. The substituents are present at second carbon and third carbon. And what are the substituents that are present on the parent chain? The substituents that are present on the parent chain are CH3, CH3. So 2 methyl groups are present at second and third position on a 6 carbon parent chain. Simple. Okay. So first you have to select the continuous carbon chain or the having maximum number of carbon atoms, and select that as the parent chain based on the number of carbon atoms that are present, and number the carbon chain such a way that the substitution position or the substituted carbons get the lowest possible number. If the two or more substituents are present, their sum should be the locant, sum of the locants should be the lowest possible number, and then identify the substitution that is present on the parent chain, the alkyl that is present, and then name that compound according to IUPAC guidelines. So, in this case at second carbon as well as at third carbon we have substitutions. So, then what are the substitution that is present? CH3, CH3. So, it is a methyl. So, how many times it is present? It is present 2 times. So, it is 2, 3 dimethyl. 2, 3 dimethyl. How many carbon atoms are present in the carbon chain? 6. So, parent is hexane. So, here hexane indicates the parent, alkyl group that is substituent is indicated here, the number of time that is present here, and the numbers 2, 3 indicates the position of the substituent present on the parent chain. It is very easy, students. You can, once you practice 2-3 examples, you can easily handle how to number, and it is easy also to name the substituted alkanes in the IUPAC nomenclature system. Okay. So, do not worry, do not bother also. Right. Looking at some more example with respect to the zigzag fashion, let me take the same 6 carbon chain, and now let us assume that the substituents are present at these 2 positions. Okay. Or let me take one more substitution, and one more substitution is present at this position. Okay. So, this is the molecule that they have given for us to name according to IUPAC concept. Then we have to select the longest continuous carbon chain, and I have taken the straight chain as a longest continuous carbon chain. If I take the longest chain as a straight chain, so the numbering can be done in such a way that the total number of carbon atoms that are present in the parent chain is 6. So, 6 carbon means the parent name is alkane. So, alkane, that is hexane, and if you observe the position of the substituent that is present, on second carbon we have substitution, on third carbon we have substitution, fourth carbon as well as on fifth carbon we have substitution. Okay, substitution is present on second carbon, third carbon, fourth carbon and fifth carbon, right. Now, if we observe the substituent that is present in this case in all the positions, second position, third position, fourth position and fifth position, all are methyl groups. So, how many methyl groups are present? 4 methyl groups are present. So, we are going to use the term tetramethyl. So, tetramethyl. So, I am writing the substitution name first, tetramethyl, but where these 4 methyls are present, tetra means 4 methyls are present. So, where they are present, what is their location, on which carbon atom they are present. So, in that case I have to write the numbers like 2, 3, 4, 5, then hyphen tetramethyl. How many number of carbon atoms present in the straight chain? 6 carbons. So, the name should be hexane. So, it is 2, 3, 4, 5 tetramethyl hexane is the name of this particular compound. Okay, right. Let me take one more example, and there are some instances where you may get confusion with respect to the selection of the longest carbon chain. For suppose they have given us like this. So, they have represented the molecule in zigzag fashion, and they are asking us to write the IUPAC name for this compound. So, if you go in a straight fashion, first carbon, second carbon, third carbon, fourth carbon and fifth carbon. So, if we go in this direction, we are getting only 5 carbon atoms in the straight chain, and if we move in this direction 1, 2, 3, 4, 5, 6. So, here we are getting only 6 carbon atoms. So, the perfect numbering or perfect selection of longest continuous carbon chain is to select the two ethyl groups that are present. See, if we are going in this direction, so this should be the carbon labeled one, this should be the second one, third one, fourth one, fifth one, sixth one, seventh one. Okay. So we have to select in this direction. So this contains maximum number of carbon atoms. How many carbons are present? 7 carbons. 7 carbons means what should be the name of the parent chain? Parent alkane is heptane. 7 carbons, hept. ANE is used for indicating the saturation that is present. So it is heptane. Okay. And now if you observe the substitution, where the substituents are present? The substituents are present on the carbon which is labeled 3, on the carbon which is labeled 5 or given number 5. Okay. So at third carbon we have one substitution, at fifth carbon we have one substitution. So here if you observe the substitution that is present, in this case we are using the similar substituents that are present, we are discussing the similar substituents on the parent chain. So methyl groups are present at fifth carbon as well as third carbon atoms. So in that case, how many times it is present? It is present 2 times. So I write it as dimethyl. So 2 times the methyl group is present. Where the methyls are present on the parent chain? At third carbon and fifth carbon. So I am writing it as 3, 5 dimethyl. How many carbons are present in the parent chain? 7 carbons. So I am using the heptane as a parent name. So the total IUPAC name of this particular compound is 3, 5 dimethyl heptane. 3, 5 dimethyl heptane is the name of the compound. Okay. So it is very easy to name the substituted alkanes according to IUPAC. First and foremost thing is to select the longest continuous carbon chain. Okay. Once you select the longest continuous carbon chain, the parent name is decided based on the number of carbon atoms present. After that, we have to look at, or we have to write or give the numbering to the carbon chain in order to indicate the position of the substituents. Okay. So how to give the numbering? If we have only one substitution on the parent chain, so that carbon should get the lowest possible number. But if we have 2 or more substituents on the parent chain, so the numbering should be given in such a way that the sum of the locands of the substituted carbon should be the lowest possible number. When you go for the sum of the locands, we should get the lower value. So that is the correct way of numbering. Okay. Right. If you follow the rules for longest carbon chain and lowest sum rule, you can easily write the IUPAC names for almost all the substituted alkanes. Okay. Right. Now let us move on to the complex substituent. When the complex substituent is present on the parent chain, how to write the name of that particular substituent? So how to decide that the complex substituent is complex? If the substituent that is present on the parent chain, if it is going to have some branches in it, okay, if the substituent which is present on the parent chain has some branches, some more branchings, some more substitutions, then that substituent is taken as complex substituent. If the substituent which is present on the parent chain, if it is going to have some more substitutions within that chain, in that case that substituent is taken as complex substituent. So when complex substituent is present on the parent chain, in that case it is named as substituted alkyl group. Of course, the numbering given in such a way that the carbon atom of the substituent which is directly attached to the parent chain always given number 1. Okay. In order to name that substituent, of course when you see an example you will come to know how we are going to handle the numbering system. So the substituent that is present, the complex substituent that is present on the parent chain, it has to be named by giving number 1 to the carbon atom which is directly attached to the parent chain, and after that the name of that branched chain has to be kept in parenthesis. So we have to keep that name of the substituent within the parenthesis, and then the IUPAC name should be given. Okay. So for example, let us take an example so that you will come to know what is a complex substituent and how we are going to number and how we are going to take the name of that particular carbon or the substituted alkane name. Okay, right. Now first example is given to us. What is our priority? First we have to select the longest carbon chain having maximum number of carbon atoms. So if I am going in a straight fashion, how many number of carbon atoms are present in this chain? 1, 2, 3, 4, 5, 6, 7, 8 and 9. So if I am going in this direction, I am getting only 9 carbon atoms in the chain. Okay. So if I go in this direction and up also I am getting the 9 number of carbon atoms. Right. Let me move to the down and let me count now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now we have 10 carbon atoms when we are moving in this direction. So let me select this as the longest continuous carbon chain. Okay. So let me select this one as the longest continuous carbon chain. Okay. So this is the longest continuous carbon chain containing how many number of carbon atoms? We have 10 number of carbon atoms in it. Okay. Right. Now if you observe the substitutions, so here we have a substitution CH3. So now I am rounding the substitution. This is CH3, this is CH3. Okay. Or let me take this color so that, so they have CH3 here, CH3 here. And if you observe here, this is the substitution that is present or the substituent that is present, but within the substituent we have one more branching. So this particular substituent is called as complex substituent. The substituent which is present on the parent chain, if it has a branching within it, within that substitution if we have a branching, that substituent is called as complex substituent. Are you able to follow? Within a parent chain, on the parent chain, if we have a substituent and within that substituent if branching is present, if that substituent has some more branching, in that case that substituent is taken as complex substituent. If you observe these, we have simple substitution, there is no branching at all in this case, but if you observe here the substituent has 3 carbons, on the second carbon we have branching again. So this particular substituent, the substituent which has branching is taken as complex substituent. How to name the complex substituent? Complex name, substituent name has to be written within the parenthesis, within the bracket we have to write the name. And again here we have a substituent, so how to number this one again? So first we have to select the longest carbon chain. Now we have to go in such a way that the numbering should be given in such a way that the sum of the locant should be the lowest. So if I go in this direction, this is carbon 1, this is second carbon, third carbon, fourth carbon, fifth one, sixth one, seventh one, eighth one, ninth one and 10th one. Okay, we have 10 carbons in our hand. So 10 carbons means the name of the parent is decane. We have discussed this one. The parent name is decane. We have a substitution at the second position, that is methyl is present. At third carbon we have one more methyl. So it is 2, 3 dimethyl. But at sixth position, if you observe on this carbon, we have substitution and on this substituent still some more branching is present. So this is the complex substituent that is present. So this name, the name of this substituent can be given by numbering this chain again. So I have to number the chain in such a way that the directly attached carbon. So in this case if I observe, so this carbon is the directly attached carbon to the parent chain. So we have selected this as the parent chain which has 10 carbon atoms. So to the parent chain the substitution is attached. So when you look at the carbon that is attached directly to the parent chain, so this is the carbon which is directly attached to the parent chain. So it should be given number 1. So that carbon should be given number 1 and then number 2, number 3. So I am going in the direction. Okay. Always in case of complex substituent, the directly attached carbon atom should be given number 1. Okay, and then give the numbering to the maximum number. Again select the maximum number of carbon atoms on that substituent as well. Okay. Now if we observe here, methyl is present on the second carbon atom. Methyl is present on the second carbon atom. Right. So if we observe, we have a parent chain On this parent chain we have 3 substituents at second carbon atom, at third carbon atom, at sixth carbon atom. Okay, and now when you observe the substituents that are present, here we have methyl and methyl, so they are simple substituents, but in this case at sixth position we have complex substituent. So in order to name that complex substituent, we have to number the complex substituent carbon atoms. How to number the complex substituent carbon atoms? Always give number 1 to the carbon that is directly attached to the parent chain. That is directly attached to the parent chain. So then write the numbering in other direction and select maximum number of carbon atoms in the direction, and then again identify the location of the substituent that is present in the complex substituent. Okay. So if I number this particular, if I name this one, let me write the first methyl so that you can easily understand. So at second position I have methyl, third position I have a methyl, so I am writing it as 2,3 dimethyl, 2,3 dimethyl, okay, and at sixth position I have substitution, so I am writing 6 hyphen. As I already told you, the complex substituent name has to be written within the bracket. So I am writing the bracket now, and again when you observe the numbering in this particular carbon chain in the within the complex substituent, second carbon has the substitution, so it is methyl. Okay, so at second position we have methyl, so I am writing it as 2 methyl. Let me change the color so that you can easily understand how we are going to write it. So 2 methyl. How many carbons we have? We have 3 carbon atoms, so it should be propyl. 2 methyl propyl. I am closing the bracket. So the total name of this complex substituent I am enclosing within the bracket or within the parenthesis. So again within the parenthesis I am writing the numbering for the substitution. So at second position we have CH3, so I am writing 2 methyl, 3 number of carbon chain is present, so it is propyl, and then what is the number of carbon atom present in the carbon chain? 10 carbon atoms, so it should be decane. So the name should be decane. So at second carbon, third carbon we have methyl, so I am writing it as dimethyl. At sixth position I have a complex substituent, so the complex substituent name I am writing within the bracket, and then finally writing the parent name. Okay. So students, we will learn some more examples of the naming the IUPAC system for the complex substituent when they are present on the carbon chain. So we will see in the next class some more examples about this one. Okay. Thank you. Have a great day.